Okay, so what is the square root of 9? 3. Yep. Square root of 64. 8. 361. 19. And what about 1024? 30 what? 32. Okay. And then it was 9 squared. 81. 4 to the third. 4 to 2 to the fourth. And 3 to the fifth. 243. Okay. So just a little review of those. So these are actually like inverses of each other, not these exact ones, but like exponents and roots are inverses of each other. Square roots specifically are inverses of like a second power. Okay. So like 9 squared is 81, and then the square root of 81 is 9. Okay. So for this lesson, we are doing rational exponents and radicals. Radicals are referring to like the square roots. Rational exponents, that word rational means fraction. So basically exponents that are fractions we're doing, okay? So objective is students will be able to rewrite expressions involving radicals, so square roots or higher roots, and rational exponents, so fraction exponents. And the first thing I'm going to show you how to do is other roots. So whenever you're doing the square root, I want you guys to think about it as it's basically asking you like what number to the second power equals that, right? So like square root of 64, you're like what number to the second power is 64, which is 8. So when we get to higher roots like this, like the third root of 125, that is just saying like what number to the third power is 125. Okay, so it's like the inverse of that exponent. So I'm going to show you how to do that in the calculator for both. So if you are doing a graphing calculator, like one of the newer ones or the yellow ones, the way that you're going to do it, well, does everyone know how to do a regular square root, first off? So if you don't, it's the x squared button right here, the little, it's in blue above it, so you just hit second, and then that button, and then the square root will pop up for you to put stuff in, okay? For the higher roots, you are going to click the button that says math. And then there's specifically a third root here because it's so common. But for all the roots, you're going to use option 5. And that's going to allow you to put the number in on the outside that you want. And then you can scroll over with the arrows. And then put the number on the inside that you want. And then get your answer. So the cube root of 125 is 5 because 5 to the third power is 125. Yeah. So click math. And then option 5. So scroll down. And then enter. And then like put the 3 on the outside. And then scroll over with the arrows and put the 125 on the inside. Got it? Okay, if you are using a scientific calculator, what you are looking for, a normal square root is going to be the same button right here, the x squared, the one above it. So you'll hit second and then that button, and then you can put your 125 or whatever number for the normal square root, okay? For the higher roots, what you have to do is you have to type the outside number first. So if we're doing the third root of 125, you're going to type 3 first, and then second, and you're going to use the square root that's above that, the one that shares the exponent button, the one that has a little x on the outside. So you're going to use that button, and then your 125. And it'll know to plug the 3 in for that spot. Okay? So you're using, again, put the 3, the outside 3, then second and your exponent button, and then the 125. And it'll give your answer. Okay? And then if you have anything besides these two calculators, just look for the button that looks the same. The square root with the x on the outside. Okay? All right, so then the fourth root of 16, try that, or think what number to the fourth power is 16? Did we get it? 2. because 2 to the 4th power is 16. Does that make sense? Does everyone know how to put in their calculator? Yeah? Okay, try the got it. So you guys can think about this as like, here, it's like 5 times 5 times 5 is 125, so that's why it's 5. And then here, it's 2 times 2 times 2 times 2, so that's why it's 2. Okay. Are we done with these or not yet? Yes, no? Okay, let's do it. What's the cube root of 27? 3. The 5th root of 32? Cube root of 64? 4. And square root of 36? 6. So here, typically, we don't write a number on the outside for square roots. They're just square roots. We just know them as square roots. But there's always a 2 there if there's nothing there. Okay? Yes? Okay. Let's move on. So now we are going to practice rational exponents in the calculator, which are fraction exponents. So, I'm going to show you with both. So the difference between how you do this depends on whether your calculator, when you do an exponent, if it actually raises up to the exponent level. So on these ones, it does. So if I'm doing 16 to the 1/4 power, I'll do 16. And then your normal exponent button over here under is clear. And see how it like raises up a level to the exponent spot. In that case, you don't have to worry about parentheses or anything. So you could just do 1/4, so 1 divided by 4, and you get your answer of 2. Okay? If you are using a calculator where it will not raise up to the actual exponent, like a scientific one, then the adjustment that you have to make is, so 16, your exponent button still, is you have to put the exponent in parentheses. So parentheses 1 divided by 4 like that. What that does is it tells the calculator that the entire 1/4 is the exponent. It groups it. Whereas if you, so see how you get 2? If you don't use parentheses like that, you get the wrong answer because your calculator thinks you want it to do 16 to the 1st power, which is 16, and then divide that answer by 4. Okay? So make sure you use parentheses around your exponents if you're using a scientific or an older graphing one. So this is going to be 2. Okay, 27 to the 1/3 is 3. And then you guys try 64 to the 3/2. 5/12, yeah. Okay, and then you guys try these next ones. So the notes kind of changed during this unit because when we were doing distance learning and then in-person learning, we had to change them. So instead of it being got it's extra practice ones because we only had like half classes, so we didn't have time to do all the problems. So we're going to treat them like got it's, but just so you know, after the lesson check, all the answers to these are there. So if when you're done with these, if you want to check your answers, you can. Fine. Did everyone put these in? Yeah? Okay, what would you guys get for 81 to the 1/4? 3. 27 to the 2/3? 9? Okay. And 16 to the 3/4? 8. Yep. Okay. So that's kind of a skill that you're going to need as we're simplifying these things. So now we're going to add in variables, and I'm going to show you how to go back and forth between the two things we just did. So what a fraction exponent is. So we know that, like, I'm going to make a little side note. Let's do, like, the 3rd power. So if I have 27 to the 1/3. Okay, so let me do the cube root of 27. So let's do, what's 3 to the 3rd power? 27. And then what's the cube root of 27? 3. So do we see how these two things are related? How they're complete inverses of each other? Now, the way that a fraction exponent comes into play. 27 to the 1/3 power was what? 3. So these two things are exactly the same thing, okay? So a fraction exponent, what that means is like a root of that number. So let us sit for a minute, okay? So these two are exactly the same thing. So that's why this one, 16 to the 1/4 is 2, because 2 to the 4th power is 16. It's the root still. So if we go down here and look, basically what's going to happen, so here's some vocab. We call like a square root just that symbol, since it's not just a square root anymore. That's called a radical. The outside value is the index, and then underneath is the radicand, just so you know like what it's asking you whenever it's in the directions and stuff. So basically how these fraction exponents work is that the denominator of the fraction is what comes around to be the index. The numerator of the fraction stays as an exponent, okay? So this, the bottom, becomes the index, and the top stays as an exponent. And then if it's just 1 over that, then the first power, that's why it doesn't really matter, okay? And then these two things are exactly the same. You will see it both ways. So the numerator can either be the exponent on the inside, underneath, or it can be the whole thing to that exponent. It's going to equal the same thing every time, okay? So the next ones are just converting back and forth between the forms. And parentheses are like the biggest deal here. So for A, there's no parentheses on that one. So first you have to ask yourself, is the whole thing to the 2/3 power or just the A? Just the A, right? Because there's no parentheses. Does that make sense? Yes? Okay. So the 12 is going to stay on the outside. That has its own first power. And then to convert this to radical form, the denominator, so the 3, is going to become the index on the outside, so the 3rd root. And the numerator, the squared, is going to stay as the exponent. That's it for that. Okay, so just the denominator goes around. Good so far? Okay, now for B, is the whole thing to the exponent or just the A? The whole thing, because of the parentheses, right? So what do we typically do whenever we have an exponent outside parentheses? Distribute, right? So let's distribute that power. So we have 32 to the 4/5, and then A to the 4/5. Now what you're going to do is you're going to put that in your calculator to see what that equals, 32 to the 4/5 power. That will not always equal something. The ones that don't, the more complicated ones, you're going to do algebra 3-4. For this year, this will always simplify into something, okay? So what's 32 to the 4/5 power? 16? 16, okay. 16, and then we'll convert that over, so what number is going to go on the outside? Yep, the 5. And what number is going to be the exponent? 4. Yep. Make sense? Yes. Okay, go ahead and do the next ones. So keep in mind too, guys, that part of this is knowing what to do in your calculator. So like on quiz day, I'm not gonna be helping you with how to put it in your calculator. That's what you gotta know. Okay, we good? Okay, first one, 8 to the 5 sixth power. So what's going to go on the outside? 6, yep. 6, and then on the inside? A to the 5th, yep. All right, this one, is the 5 included with the 1/3 or no? No, so the 5 should just be on the outside. And then the 3 should come to the front. And then just X. You can do X to the first if you want, but I know Math Excel won't accept that. So just don't put an X one if it's 1. Okay? And then for C, is the 27 included with the exponent? Yes. So distribute, and you do 27 to the 2/3, y to the 2/3. And then what's 27 to the 2/3? 9? Yeah? Okay. 9. And then the 3 comes to the outside, and then y squared. Good? Okay, so I want you guys to realize, like a little side note, sometimes you'll see the answer, or you can give the answer, like, so cube root of y squared is the same as the cube root of just y with the squared on the outside of, like that. So those two things are the same thing, whether the exponent is on the inside, underneath, or on the outside, like that. Just so you know, and you'll see it both ways, okay? Okay, so now we're gonna do the reverse. So we're gonna take the radical form and turn it into exponential form. So for A, what's that gonna be? S to the what? Yeah, S to the 2/3. Okay, and then for B, the 12 is just staying 12, and then X to the what? Yeah, 4/3. Okay, so for C, now both of those are to the 5th power. What number is invisible here? So like a normal square root is what index? 2, yep. So we're going to keep the parentheses and just bring that 2 around. So I have 4y to now the 5/2 power. And then are we allowed to leave parentheses with exponents on the outside? No. What do we normally do with this? Distribute. So it's 4 to the 5/2, y to the 5/2. And then just figure out what 4 to the 5/2 is. Yep, so 32y to the 5/2. So you're just simplifying like the coefficient. Okay, we good there? Yeah? Okay, the next one's a little bit different. There are multiple things under here, but there's no parentheses where they have the same exponent. So we're going to do the same thing, kind of, but we're going to do it to its individual exponent. So what exponent does 256 have right now? That's 256 to what power? It's not the 8th power because there's no parentheses. First, yep, so that's 256 to the 1st power, right? And then a to the 8th power. So when you bring that 4 around, you're just going to put it underneath both of them. So you'll do 256 to the 1/4, and then a to the 8/4. Because 256 has a 1st power. And then figure out what 256 to the 1/4 power is. What? 4? 4, okay. 4, and then a, and if you can simplify any exponents, like fractions, then do it. So what's 8/4? 2, yep. So let's do 4a squared. And then go ahead and do the next two. All right, so for A, what do you guys get? B to the what? Yeah, B to the 3/5 power. Okay, and then B does not have parentheses, correct? So what exponent does 27 have? A 1. So you should have 27 to what power? 1/3. And then D to what power? 5/3. And then what's 27 to the 1/3? 3. And then can I simplify that? No. So we will just leave it like that. Good? Any questions at all? Okay. Last one. All right, you can estimate the metabolic rate of living organisms based on body mass using Kleber's law. The formula R equals that relates metabolic rate R measured in calories per day to body mass M measured in kilograms. What is the metabolic rate of a dog with a body mass of 18 kilograms? So what metabolic rate is it's basically like the amount of calories that you need to consume every day to literally just keep you alive. Like just sitting, just to keep like your organs running, to keep your blood pumping, your brain working, all of that. So like just to keep you normal, okay? Now, is that to say if you don't eat that amount of calories that day that you're gonna die? No. What does your body use if you don't eat as many calories as you need? Yep, stored fat. So that's like the whole idea behind losing weight. That's at its basis, like what a calorie deficit is. So eating less than what you need as for this, okay? So 18 kilogram dog, where am I gonna put that in? Where's the 18 gonna go? Yep, so we have R equals 73.3, and then the 4th root of 18 to the 3rd. And honestly, you can just type that whole thing into your calculator, but there's a specific way you have to do it, okay? The graphing one is pretty straightforward. The scientific one is the one where you have to kind of be careful. Because we have something being multiplied out front here, and when we do this root, that's in front, so you're going to have to type it in like this. If you have a scientific one, or to watch either way, because it's good for everyone to see. Try to get this under the light. Okay, so what you want to do is you want to do 73.3, and then times, so use the multiplication sign. So this is not the graphing one. The graphing one, you can just put it in like that. You don't have to be all fancy. Then you're going to do the outside number, so the 4th root, so put 4. And then your second, and then the X root button that we did. And then here's where you have to be careful, because the 18 to the 3rd power is all underneath that radical, right? So if you don't put parentheses, then it's going to think just the 18 is underneath it, and then your whole answer is to the 3rd power. So you want to make sure that you put parentheses, and then 18 to the 3rd, and close your parentheses. So it groups all that together underneath the radical, okay? And you get this.
How do you do on this one?
That one, you are going to you can just plug it in exactly as it's written. You can just do 73.3, and then, not a second, math, and go down to option 5.
Yeah.
And then, just kidding, and put the 73.3 in. Okay, so then do multiplication. 73.3 times, and then math, then you'll be able to do the 4 on the outside, and then the 18 to the 3rd on the inside. Yeah. Yeah, so just add a multiplication sign, so it doesn't automatically put that there. So we're going to round that to the nearest whole number, so we're going to say about 641 calories. So if the dog is not doing anything besides just staying alive, just being completely sedentary, 641 calories will just like even out. That's exactly how much this dog needs to like stay alive. If the dog eats less than that, then the body's going to burn stored fat so to get that energy that it needs. If the dog eats more than that, then it's going to gain weight. Okay? All right, so go ahead and do the next one. So a man with a body mass of 75 kilograms. So this is about a 165-pound man. Okay? It's like an average adult male.
So the same thing at 73.3, but you just put
Yeah, so you'll just put the 75 in for the M. Yeah. Wait, just on my desk. Thank you. Did you get an answer?
1868.
Yeah. Yeah, so it should be about,
1869.
I think at 1868. So 1,868 calories to just stay function.
But that one's at 9, so it should round up.
It's 1,868 what?
0.099.
But it's 0. So it'd be 0.1 if you were to round to that, but it's, yeah, the 0 tells you to stay down. Yeah. So yeah, if it was like 0.9, not 0.09, then you'd round up.
What about like 0.2?
Then still down. So the very first decimal place would have to be a 5 or above. All right, any questions on this? Okay. Do the lesson check. All right. Yeah. So you can either do the 125 to the 4th underneath or do put parentheses around it with the 4th on the outside, yeah. I'm also going to pass out your guys' tests while you're finishing up with this, and I just need you guys to throw them in your files when you're done looking at them. I'll open that, and then the retake, remember you get one test retake a quarter, so check if you're eligible if you want to retake this one, and the retakes are Thursday during class, okay? But I'll come bring you your tests, and then I'll open up that drawer. Huh?
When can I take the test?
Whenever you want / are ready. Did you finish the review for it?
No.
Maybe do that first, and then once you're done with that, then. Just make sure don't have it, because it'll take me down. Remember, you guys are the red folders, and it's alphabetized by last initial. So whenever you're done looking at it, you can just find your folder from there, and I'll put the answers up for the left.
Miss Angie, how do you put number 3 in your template?
So parentheses are with the parentheses first,
So they got like parentheses.
and then do the math, yeah, and then you just have to use the right arrow. Like once you're done on the inside, you use the right arrow to get out of underneath,
So I do
and then the inside, and then use the right arrow to get out from underneath the radicals, so you can finish the parentheses,
like this.
and it'll pop back out to this normal level after you're done underneath. And then you can close and then do the exponent. Or you can do it in pieces too. You can figure out what just the third root of 125 is and then do that to the fourth power separate. Okay, answers. Okay.